Hello everyone, my name is Norman LeMay and I am your statistical instructor. So in this video I would like to talk about hypothesis testing for two population proportions. In this video I would like to go ahead and lay the foundation and the framework for this, as some of those equations I'm trying to say can become a doozy. So let's get started. So by means of introduction to hypothesis testing regarding two population proportions, let's just start off with a simple example. So 5280 Statistical Consulting is interested in investigating if the incident rates of type 2 diabetes has changed going from 2010 to 2019. All right, so in order to investigate this, we have to take a look, see at what's going on. So there was a proportion of people that had type 2 or were diagnosed with type 2 diabetes back in 2010, and there are a proportion of the population that has been diagnosed with type 2 diabetes here in 2019. So what we have to do is go out and collect some data from 2010 and collect some data from 2019 and see what happens. Has there been a change or has it increased? Pretty much taking a look at an increase. All right. So here what we'd like to do is to go ahead and define P1 to be the proportion of people that have type 2 diabetes in 2010, and we'll go ahead and define P2 as the proportion of people that have type 2 diabetes in 2019. All right. Now we got to go back and take a look at our research question. So let's just note that our research question pretty much is along the lines of, has the proportion of type 2 diabetes, or has the proportion of the population of people that has type 2 diabetes increased over the past 9 years? So let's just note that this research question, or this needs to be phrased accordingly. So let's just note that this appears to be asking us, is there some kind of a difference between 2010 and 2019? So this is a statement of difference, and we know that statements of difference involve the alternative hypothesis. So in this case, we'll take a look and formulate the alternative as P1 is less than P2, all right? And then our null hypothesis, remember the null hypothesis is a statement of difference, all right? Or of non-difference, I should say, sorry, is a statement of non-difference between, in this case, two population parameters. So in this case, the null hypothesis says, no, there is no difference between the proportion of people with type 2 diabetes. So notice that we can formulate this as P1 equals P2. All right, so now that we have our hypothesis set up this way, a lot of times or later you will see that when you go to use StatCrunch, StatCrunch doesn't formulate the null and alternative hypothesis in this form. And in fact, a popular thing to do is to formulate the null and the alternative as differences. So what we can do then is we can formulate this as a difference, and all we do is move P2 to the side of P1 by subtracting P2 from both sides. So we can write our null in the form P1 minus P2 equals 0, and let's keep that in mind because we're going to come back to that here in a few minutes. And P1 minus P2 is less than 0. All right, so again, we have to go out now and we have to collect some data from 2010. So note that our data is going to give us this P hat 1, and then we have to go out and collect some data, and we have to go out and we have to have this P hat 2. All right, so then we have to compare P hat 1 and P hat 2. And to do this comparison, we formulate this thing called p hat 1 minus p hat 2. So this becomes a new statistic. Now, p hat 1, we already know the distribution of this. And p hat 2, we already know the distribution of p hat 2. So now notice that p hat 1 minus p hat 2 forms a new random variable, which consequently forms a new distribution that we have to take a look at. All right? So let's just recall that p hat 1 is distributed normal with p1, and then that ooky looking square root looking thing. And let's note that p hat 2 is also distributed normal, and p hat 2 has its mean as p2, and then that standard deviation looking sort of thing. So then the question is, when I form the difference of p hat 1 minus p hat 2, notice I'm taking the difference of two normal random variables. So the question would be, well, is the distribution of two normal random variables also normal? And it comes out, yes, it is. That's one of the nice things about the normal distribution. This is not always the case, but for the normal distribution, my lovelies, this is what it is. So the distribution of p hat 1 minus p hat 2 is this big old looking thing. It's p1 minus p2, the square root, and then you have the sum of those two variances. So now that we have the distribution property of p hat 1 minus p hat 2, we can now go into discussing the test statistic for the difference of two proportions. All right, so let's just recall that a test statistic is something that's in the form involving a z-score. It's basically a fancy schmancy z-score. So let's just recall that the z-score, or the z-test statistic, or any test statistic for that matter, is always something involving the data minus something under the null hypothesis divided by the standard deviation of something involving the data. Okay, so with that being the case, then something involving the data for our test statistic has to be the difference of the p hats, and then something involving the null is going to come along involving the null, and then we need that standard deviation. So since we're dealing in normal, it's no surprise that for proportions, our test statistic is going to look something like this. But do you remember what p1 minus p2 under the null hypothesis is equal to? I told you it was coming back. All right, so this standard deviation here, statisticians, long story short, have decided to, for gory detailed reasons I prefer to kind of leave out, and that is they decide to do what they call a pooled proportion. So basically they just throw everything from P1 and P2, we throw it together, and then we form this new thing and kind of push everything together. It has very nice results, and there is strong evidence and strong reasons why we do this. So rather than looking at that denominator, this is our formal test statistic. So let's just note that our test statistic is p hat 1 minus p hat 2, and notice that p1 minus p2 under the null was equal to 0. So we don't need that part, so that kind of cleans up a little bit. And then notice now we have this new p hat, and this new p hat is defined to be x1 plus x2. So the number of successes from population 1 plus population 2 divided by the number of trials in N1 and the number of trials in N2. All right, so that's how we form our test statistic, and recall that the test statistic tells us how far away that the difference of the proportions is from 0. Okay, so that wraps up this portion of our discussion regarding proportions. Please note that I do not recommend, yet again, I still don't recommend you doing these using your calculator, because your orders of operations can get messed up very easily. And so use StatCrunch or your TI calculator. Use some sort of technology to do this, okay? So keep that in mind, and please use it. All right? All right, so I will see you in the classroom. Adios.